Hey guys, these are the guided notes for volume of pyramids. This is really similar to the other volume stuff. The biggest nuisance for this section is there's going to be a fraction in the formula, but otherwise it's going to function pretty similarly. So we are talking again about a pyramid, which I'm assuming you've seen the pictures of the ones in Egypt. It's basically what we're talking about. It's a shape where the bottom, usually it can be flipped over on its side, but the bottom can be any polygon where you're typically going to look at squares. The other faces are all triangles, though. That's how they come to a point. The formula for the volume of a pyramid is still going to use area of the base times the height, but you're going to have to take a third of that. So remember, capital B we use for area of the base. If that's a square, which it will be a lot of the times, that's when you're just going to use length times width. The height is going to be what I use for H. Just make sure it does go from this apex tippy top section straight down to the middle of the base. Don't use any that go slanted sideways. That is not the same thing. So if you ever have one, I guess there's not one drawn here, but if I had like a square base drawn, but this apex here was not over the center, so it's just kind of like crooked, like maybe it's over here instead of being centered. Since the whole pyramid ends up being kind of smushed sideways, we're still going to call that an oblique shape. So we've so far had oblique prisms, we've had oblique cylinders, and now we get oblique pyramids. So we're going to find the volume, and I'm trying to think what I want to do. Pretty sure we're just going to skip this part here where it has us convert, because I know it's not in any of your homework, so I'm going to assume he's not going to put it on any of the quizzes or tests. So we're going to find the volume, and we're going to do this in cubic meters, and we're going to skip this portion of it. So like I said, we're going to use 1/3 times the area of the base times the height. And when I look at this pyramid, I can see that the base is a square, so I'm going to be thinking 1/3 length times width, and then we're going to multiply by that height. So the length and the width of that square are both 5s, and the height is a 12. So one thing I sometimes recommend when doing this section, especially if you don't have an actual calculator, if you're relying on a phone or something, do this portion first. So I'm going to do 5 times 5 times 12 first. So I know I need to take 1/3 times 300. And then you could do like 1 divided by 3 times 300. I guess I could show you what I mean by that. Whoa. Sorry. It's the stand I use for my iPad here. Calculator. Okay, so you could just do 1 divided by 3 times the 300. You'll notice I never hit equals until the very end so that I didn't use a rounded number. So 1 divided by 3 can be used as your fraction, but you'll notice that's the same thing as just doing 300 divided by 3. Could have gotten you that, so you still get 100. So when you see the 1/3, it's the same thing as saying, oh, divide that big number that you just got by 3. So 300 divided by 3 is 100. That's how many cubic meters are in that pyramid. So 1/3 area of the base times the height. So the table shows the approximate measurements of the Great Pyramid of Giza in Egypt, that's the famous one, and the Pyramid of Kukulkan in Mexico. Approximately, what is the difference between these two volumes? So we're given the height, and it already gives us the area of the base. They're giving us capital B. So I have 2 pyramids I need to compare, Giza and Kukulkan. Both of them are pyramids though, so they're both going to use 1/3 area of the base times the height. Now, the Giza one, I'm pretty sure the ones in Egypt have squares at the bottom. I don't really know for sure, but it doesn't matter because I already know what to use for capital B. We're going to use that 52,900 times the height. which is told to us to be 147. So I'm going to ignore the 1/3 temporarily. 52900 times 147. I get a very large number. 7 million some odd. So 7,776,300. When I divide that by 3, that's nice. This one divides evenly by 3. 2592100. So the cubic meters in the Egyptian pyramid is 2,592,100. If we go to the Kukulkan one, it's still a pyramid, so I'm still going to use 1/3 area of the base times the height. And just as before, the area of the base is told to us. We don't actually have to calculate it. This one has the area of the base of 3,025. And it says the height is 30 meters. So I'm going to multiply 3025 times 30. And then I'm going to multiply that by 1 divided by 3, or just divide that number by 3. You should see 30,250 cubic meters, which is not small. 30,000 cubic meters is large, but compared to the Giza one in Egypt, 2 million, that's why that's called the Great Pyramid, and I don't even know how to pronounce the other one because it's so much larger. So if it wants to know the difference between these things, I need to subtract these two volumes. So I'm going to take the 2 million number and subtract the 30,000 number, and the difference in the volumes of these two different pyramids is 2,561,850 cubic meters. The one in Egypt is so much larger than this one that's in Mexico.